Okay, right, so best thing about Monopoly is counting the money. So 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000. Oh, lovely. Right, now let's imagine that I'm going to put that money, I'm going to put it into an investment, I'm going to put it into my bank, okay? Now, bank's told me that they're going to pay me 5% interest every single year, so that stays away. All right, so 5%. So 5%, how do I work out 5% of 8,000? So a couple of different ways of doing it. So 8,000, now I could divide by 100, times it by 5, but actually what you should have been looking at recently is you should have been looking at doing that as the best way of finding out 5%. So 8,000 multiplied by 0.05 equals 400. If you multiply it by 0.5, by the way, you're going to get 4,000. That's a mistake and a half. Right, so 400. Right, so I get another £400. 3, 1, 2, 3, 4. Right, I wish the interest worked exactly that way. So there's another £400. Right. What about then? So that's now gone into there. Right, I'm going to get another 5%. So what's wrong with this? So I'll get another 5%. So another 400. Is that right? Right, what I've done there, that's what we call simple interest. So if I say it just keeps increasing by the original £400, that's called simple interest. Okay? Now a lot of people make a mistake with this. But actually, if you imagine what happens really at the end of the first year. So at the end of the first year, I've now got £8,400. So that's also going to gain interest. And this is why this is called compound interest. Because you get interest on the interest. Right? That sounds a bit odd, doesn't it? I get interest on the interest. So it's 8,400. So now I'm going to work out, so 8,000, so how much more interest do I get now? So 8,400 multiplied by a 0.05. So, what's that going to give me? 8,400 multiplied by 0.05, and that equals 420. So I'm going to get another 400. I'm not just going to get 400. I'm going to get 420. 1, 2, 3, 4, and plus. So that represents the interest on the interest. So that's going to now give me, I've now got 8,820. Right, let's have a look at a shorter way of doing that, alright? Because otherwise that's going to get, it's going to take a while, isn't it? So, come and have a look at this. So, let's think about my original investment, 8,000. Now, working out 5% is fine, but actually, think about this for a moment, about what this is. Why am I going to multiply it by 1.05? So that represents the 5%, and the 1 represents the 8,000. So that's a shortcut to working out 8,000 multiplied by 1.05 takes me straight to 8,400. So it actually saves me needing to work out 400 and then adding it on to the original 8,000. Now what about if we had our 8,000 multiplied by 1.05? What about if we keep it there for 2 years? Multiplied by 1.05 again. What about 3 years? Multiplied by 1.05 again. Or I could do that, because that's the same. 8,000 times, what about if I leave it there for 20 years? There we go. And the last thing to consider, before we get on to a few more examples, is what about if it depreciates? Sometimes I might have something, let's imagine I've got my magical calculator, okay? And my magical calculator is worth £10 when I buy it, okay? Now each year it's going to depreciate by, let's say it's going to depreciate by 5%. So that means it loses 5% of its value. So therefore, if you lose 5%, if I chuck 5% away, it means find 95%. Okay? And then if I had it for 5 years, I put a 5 or a 6 for 6 years. Okay? There we go. Right, I've got some more examples for you. Right, that we're going to have a little look through. And you see what you make of those, okay? And then there's a few questions at the end. But now, made a nice cake earlier, so I'm going to go and munch that. Okay? Alright? Good luck with your questions, alright? So then, let's have a little chat about compound interest. So we've talked about kind of difference between compound interest and simple interest. And compound interest is interest on the interest, and then it goes the same the other way, depreciation. Okay, so I might have something that depreciates by a certain percentage every single year. All right, so the objective today is just to go through a few examples, and then you've got some questions to do. All right. So let's have a little look at some of these. Okay, so these ones in your PDF, right? So I invest some money in a building society account which pays 5% interest each year. Find the value of the investment after 2 years. So that's £300. So if I want to increase by 5%, now I could work out 5%. Ooh, right, okay then, and then add it on to 300. But the best way of doing this is to multiply by 1.05. Okay, so the 1 represents the 300. So if you multiply something by 1, well, it doesn't change it, does it? And then the 0.05 represents the 5%. So we want to invest this for 2 years. So what's actually going to happen is that you're going to do that again. Okay, but then why not just do it like this? There we go. All right, that's much better. So we're actually squaring it. All right, so we're timesing it by 1.05 and then multiply it again by 1.05, and then we could just plump that in our calculator in one go. Okay, so 300 multiplied by 1.05 squared equals whatever that equals, 330.75. All right, so I invest £600 in a building society account which pays 7% each year. So 600 multiplied by 1.07, so the 1 represents the 600 and then the 0.07 represents the 7%. 3 years saves me writing 1.07 times 1.07 times 1.07. I'm not really that interested in the answer. Yeah, okay, the answer is obviously important, but this is the important bit. 600 multiplied by 1.07 to the power of 3. Here we go, and the answer is 7350 due to 2 decimal places. Okay. Oops. Bit of a weird pound sign. Right, there we go. There's the answer. Right, let's quickly whiz through just a few more examples, and then you can have a go at doing a few questions. Okay. So let's have a look at this one. So it's the same question, really, isn't it? Look, let's just write down the detail. Okay, I'm not even going to bother filling out the actual answer here. I'm interested in just the detail, what you would actually type into your calculator. Right. So we've got 700, and we're going to multiply that by, so it's 3% interest. So that's 1.03, and find the value after 4 years. There we go, and we would work that out. All right. Now, if you think you got it, just stay with it for a second because something's going to change. So I invest £900 in a building society. So 900 multiplied by 2% interest, 1.02. Whoa, 18 years. There we go. And type that into your calculator. All right. Right. Now, those are interest questions. What about depreciation questions? Okay. So what's happening here? A car costs 13,000. Its value decreases by 12% each year. Right. 13,000. So it's going to be something to the power of 2. Okay? So how do I decrease by 12% each year? So what I want you to imagine, so if you're decreasing by 12%, that's like saying, well, if I chuck 12% away, how much am I keeping? So decreasing by 12% is like saying find 88%. Okay? So multiply by 0.88. There you go, and work that out. Now it is worth just typing in just quickly, just have a little look, just to make sure it gives you the sort of answer that you're expecting. Okay, it's gonna go down. All right, and we've talked a little bit about kind of using your calculator in the right way. So what's that? 10,067.2. That's 20 pence. Okay, right. So let's just write down on the others what the calculation is that we have to do. Now remember, if you think you got it, move ahead of me. 15,000. So it's something to the power of 3. Decreases by 21%. So if it decreases by 21%, that means I chuck 21% away. How much is left? It's like saying find 79%, because 100% is everything. So if I decrease by 21%, it's like saying find 79%. So that's what I want to do on my calculator. Alright, and so a quick look, just a couple more. Okay, same idea. So 16,000, value decreases by 8%, so multiplied by something to the power of 5. Okay, so if I'm decreasing by 8%, that means find 92%. So that's multiplied by 0.92. And then my car costs 13,500. Depreciates by 30% each year. 9 years. So that'd be find 70%. So that'd be like that. Now I'm just interested to see what that actually is, because those of you know anything about values of cars, it doesn't really necessarily kind of work exactly that way. But let's have a little look. It's going to be multiplying by 0.7 to the power of 9. Let's see what sort of number gives us. So it gives us 544.77 pounds. Now, in reality, value of a car after sort of 9 or 10 years is not a lot, annoyingly. And then weirdly as well, but then if you've got a car, yeah, how does this make sense? So if you've got a car that's like 10 years old, right, it's not worth a lot of money. If you've got a car that's 50 years old, it might be worth quite a bit. That doesn't make sense, does it? All right, because things don't always work in a way that you think they might work. Right, okay, enough of me waffling on there. Right, you're going to go doing some questions. Just be a little bit careful on question 2 on your PDF, because it says here an annual interest rate of 4.8%. So in other words, it's asking you to increase by 4.8%. So I'm just going to write on here for you. That's the same as multiplying. So if it was 4%, it would be that. So if it's 4.8%, it's that. Okay. And then on C, the same sort of idea. That'd be, so that would be 7%. That's 7.2%. Okay. Right. So you can have a go at just doing those few questions. Okay. It's not too much, so it shouldn't take you too long. All right. Okay. All right. Well done.